In this video, we will be presenting how a database administrator can manage database security through principles, securables, and permissions. Now we are going to talk about principles. We will be covering what are indivisibles and collection and how it can be managed. But first, what are principles? Principals are individuals, groups, and processes that can request access to securables. As we mentioned, there are two types of principals: indivisible and collection. Indivisibles are entities that exist independently of other entities, such as SQL Server logins and Windows logins. Collection represents a collection of entities that are treated as one even though each one exists as an individual entity. Examples of collections are Windows groups and roles. Roles are predefined set of permissions given to user to make it easier to manage the security of database. There are two types of roles: database level roles and server level roles. Principles can be defined and managed at three levels: in Windows, SQL Server, and database. In Windows, it is managed by assigning permission to the Windows groups. In server level, there are server roles as we have mentioned previously. On database level, there are database user, database role, and application role.
These are the three separable scopes that we'll be focusing on. In server, we have two scopes, namely logins and roles. In logins, we have Windows Authentication Mode and Mixed Mode. In Windows Authentication Mode, we have the local security policy, where administrators can set the password policy, such as the complexity and expire passwords. The advantage of this is, users can use their Windows credentials to connect into their SQL server, and there is no need to remember multiple credentials. The password matches the password policies set by the administrator. Windows Security Identifiers provides an unique identity for users and groups. SQL Server then compares the SID with the master login table.
And the disadvantage is that only Windows users can open a trusted connection, and some third-party clients are unable to support this mode. Next, we have Mixed Mode. This mode enables both Windows authentication and server authentication. So the advantage of this is any users can use, and that includes third-party clients, and it also adds a second layer of security to the database. However, the downside to this is that users will have to remember multiple credentials, which is quite difficult for many users. So why do we have to create a login account, and why is it important? It is because we want to ensure that only assigned users can access the server or the database. We also have TSQL, which stands for Transact SQL. It is essential to using SQL Server. All applications that communicate with an instance of SQL Server do so by sending Transact SQL statements to the server. We can create a login account for the users using the create login statement. The syntax for Windows login and SQL logins are a little different, but they have similar options like check policy and defining a default database. For auto login, it is only for SQL logins, and drop login, where the database administrator can drop a login account by dropping a table.
In roles, we have fixable roles. The four common roles that are used often are sysadmin, where members of this role can perform any activity in the server. The second one is server admin. Members of this role can change server-wide configuration options and shut down the server. The next one is security admin. Members of this role manages logins and their properties, that they can either grant, deny, or revoke server-level permissions. They can also reset passwords for SQL Server logins. And last, we have public. This is where every SQL Server login belongs. If a server principal has not been granted or denied specific permissions on a securable object, the user will inherit the permissions granted to the public on the object.
In database securable scope, it consists of database roles, database users, and a type of containment database. In database roles, there are fixed database roles, custom database roles, and application roles. Fixed database roles has roles like DB data writer, DB data reader, public. There is also roles to deny data reader, deny data writer to the particular database, and DB security admin to manage the security of the database. These roles cannot be deleted or changed, and when each database is created by default, these sets of roles are also being created. Custom database roles can be defined by the database administrator. Like in a practical, we create select only database role that can do a select query on the student table. We can create another custom role that can do only update or insert operation on the student table too. Application roles provides permissions on objects. Through an application, users get the permissions associated with the role only when running the application. In practical, we created ENT app role to do only select query on student table, but not any other operation. To use an application role, the database users need to provide the role name and password before they can do a certain operation according to what the application role has set. In database users, it can be categorized in two groups: special users and defined users. Database users is used to control who can access certain database and what operation can they perform in each different databases. Special users are DBO and guests. DBO is a default account that comes with a database when it's created and it cannot be deleted. Sysadmin server role will automatically be a DBO user on every database unless specified. Guest users by default are not allowed to be connected to database unless the database administrator allows that option. It is allowed to those who have server login without user accounts to access database. It should have limited functions, as all servers login can use this user to access any database. Defined users are those we created in practical, like Elsie, Tom, and Harry. These users' account will be mapped to the same server login name if not specified, or it can be like the case of mapping Elsie, a user account, to Ellie's server login, which is a different name. The TSQL statement to create a user login are as follows. Partially contained database is used when in the initial deployment to overcome compatibility issue when moving or restoring database, or for failover solution. It can let database owner have more control over their database than sysadmin. This is a current containment setting that we use in our practical practice. A database can enable this feature on its creation or when the database is created earlier before. After setting the containment, it can be altered when the database administrator needs to change the configuration. Database administrator can then add a user in the contained database to be a database owner and to grant permissions to whom can perform operation on this database. In a contained database, there is no longer associated with logins on the instance of SQL Server. You just have to create a database user with password in a partially contained database and then directly connect to that database. This also reduces the dependency on the SQL Server when user authentication can be done by the database. But this feature is only available in SQL Server 2012 or newer. Database that is dependent on the SQL Server instance are otherwise called as non-contained database. Those earlier versions than SQL Server 2012 are non-contained database. Unlike contained database, non-contained database is dependent on database settings and metadata required to define the database on the instance of the SQL Server database engine. A database schema is a logical container that groups objects like tables, views, stored procedures, and etc. Then, the user login will have permissions to a particular schema, which only the user can have access to the objects within that schema.
Now we are going to talk about permission. What are permissions? Permissions define the type or level of access that is granted on securables to principals. A principal can have access to a resource only if granted the permission to do so. There are three areas to cover for permissions. Types of permissions, grant permission, and states of permission. There are two types of permission, statement and object. Statement permission allow user to create structure such as create database, create table, create view, and create procedure. It has nothing to do with the stored data. It is best to restrict statement permission to DBA, assistant DBA, and developers. Object permissions control how user work with the actual data, such as who is allowed to read from, write to the data. Object permission also allow user to take ownership of the table, alter the table, and etc. Permission can be granted directly or indirectly. Direct permission is when the permission is given to the user account. Indirect permission is when user is in a group or assigned to a role with permission on securable. There are three states of permission: grant, deny, and revoke. Grant allows users to use a certain permission. Revoke takes away any of the previous permissions, such as grant, returning it neutral. Deny prevents the user from getting the permission. Thank you for watching this video. We hope you enjoyed it.